Okay, I am looking at question 10, which was a transformation of a hyperbola, rectangular hyperbola. Okay, the diagram shows the y asymptote lies at y equals -2 and the x asymptote lies at x equals -1. That's the representation of that curve. So folks, I've put it down on this piece of paper. And before we're even going to look at the rest of the question, we are going to look at how that transforms this mother curve. Those three transformations that we gave you on the question paper. Okay, so I'm going to work with them for a while. The first transformation they asked us is f of x plus 3. Now remember, the question says the following: match the equation of the graph with the sketch. Now you got the sketches in the exam, we'll look at them just now. Write the number of the question and the appropriate capital letter pertaining to this particular transformed function. What would this look like? This would be -3 over, now remember the change happens at x, so it's x plus 3 plus 1 minus 2. Now what do we notice? We notice this is -3 over x plus 4 minus 2. So we're going to look for a horizontal asymptote of y is -2 and a vertical, so this is the horizontal asymptote. The vertical asymptote would move to x equal to -4. Okay, let's look at the second transformation. So we first of all working with the transformations they gave us. They said, what is f of x plus 3? So where this was a horizontal translation, this is now a vertical. So it's the given function, nothing changes with the x, but we add 3 to the horizontal asymptote. So we have -3 over x plus 1, and then we have a plus 1. Now if we analyze that again in terms of the asymptotic behavior, the horizontal asymptote would now be at y equals 1, and the vertical asymptote will still be at x equals -1 as for the original curve. Okay, the third one, look at what happened here in the third equation. The third equation, there was a reflection here, minus f of x plus 3. So the graph reflected in the x-axis. The y values that were negative, let me move this out of the picture completely there for now. The y values became minus y values. So this whole thing changed its direction to a negative. So it's the negative of f of x, which is -3 over x plus 1, -2, and then a vertical translation of 3 units. That's what happened. Okay, so let's have a look. This is then 3. X plus 1, a negative times a negative is a positive 4, plus another 3, and that gave me 3, x plus 1 plus 7. So I'm now looking out for the following graph. I'm looking out for a graph that will have a horizontal asymptote and a vertical asymptote. The vertical will be at -1. The horizontal would be at 7. So that's in fact what I'm looking for. So I'm going to go to the graphs that we were given on the exam paper, and then we're going to look for those possibilities. Let me zoom out so that we have all 6 in place. Okay, so let's see which graphs has a y asymptote at -2. There's one here at -2, and let's see where is its x asymptote. Its x asymptote, or its vertical asymptote, should then be at -4, and indeed it is. So for the first one, I would have chosen option F as my graph. So I would have said it's represented by F. That takes care of that graph. The second one, I'm looking for an asymptote horizontal which lies at y equals 1. Now here's one with y equals 1. There's another one with y equals 1, and that's the only two. So it can be one of those two. Now I'm looking for an x asymptote at minus 1. This one is at 2. This one is at minus 1. So we've hit the jackpot with number 2 lies at the graph C that we gave you. The third one lies at a horizontal asymptote of 7. Now let's search for the horizontal asymptote of 7, which is not on any one of our graphs. The vertical asymptote lies at minus 1. Okay, so there's two vertical asymptotes at minus 1. Here's one. The other one we don't have. So let us just see if we calculated our horizontal asymptote correctly. Our horizontal asymptote for this one, we had to reflect it in the y-axis, okay, because the x-axis rather, because the y values became minus y values. Let's make sure that is what the question asked us to do. The question said minus f of x plus 3 indeed. Okay, so if it's minus f of x plus 3, if we go for the minus f of x over here, we have a plus 3, and then it's still x plus 1. A minus times a minus is indeed a positive, and look at what I wrote. I wrote it's 4. So in fact this is positive 2 plus 3, which is a 5. Now that was a silly little arithmetic error, and you can see that indeed we are now on the right graph. My x here is minus 1, my y value is definitely 5. So for option 3 I was going to choose option D that lies on my diagram. Okay, so there's my final answers to this question. Now folks, you saw the silly arithmetic error I made. Heaven knows why I made it for. I don't know what I was thinking. So that was a plus 2 plus another 3 brings you to a positive 5. Don't make the same little error that I made in here. But you could see, how did I look for it? I applied each transformation to the function I gave, that they gave to me. I transformed the function and I read off the asymptotes from there, went to my graph, and then chose the correct graph to go with the correct transformation.